Sorry.
Angie, I see your presentation is kind of small. I don't know if it's just my problem or if
I don't know.
also
My
the other.
It's your problem, Francesca. I see it normal.
It's normal. Okay, fine.
I see it full screen.
Okay,
Yes,
good.
Okay. So Foremost is a public spectroscopic survey that will go on for 5 years at least at the ESO telescopes, and it is intended to complement different surveys already going on from space telescopes and missions such as Gaia-ESO, eROSITA, and Euclid. But in my presentation today, I will center only on the galactic archaeology part of the survey, which is intended to be a complement to the exquisite measurements provided by the Gaia mission. So Foremost, as I said, means 4-meter multi-object spectroscopic telescope. And the telescope is the VISTA telescope on Paranal in Chile. And Foremost has been created and operated by ESO and POSDAM as main institutes, plus lots of many other institutes around the world, in Italy, in Europe, and also in Australia. If you want to have a lot of information on Foremost, there is a dedicated messenger issue. It is already almost 3 years old, but all the information that we need to start thinking about Foremost surveys, etc., is already in there. So Foremost is a complicated instrument and a complicated survey. As I said, Foremost will be on a 4-meter telescope, VISTA, will operate as a public survey. So all the time on VISTA will be dedicated to Foremost, to the Foremost service for the first 5 years of operation. And the consortium that built the instrument and prepared the service has 70% of the time on the instruments in the first 5 years of operation. But 30% of the time was open to other surveys, the so-called community surveys. And we proposed for them a few years ago, and 15 projects have just been approved. So the slide is full of information. A few things that you really need to know is that the field of view of Foremost is a large one. It has a diameter of 2.5 degrees, so an area of about 4 square degrees. It can operate both in low resolution and high resolution, meaning 5,000 and 20,000. And the high and low resolution fibers share the same field of view and the same field. So there will be more than 2,400 fibers in the field. 2/3 of them will feed a low resolution spectrograph, and 1/3 of them will feed a high resolution spectrograph. And the two surveys and the two parts operate exactly at the same time. So if you want to have information, more precise information, details, you can go to the website just here, and you will find everything that you really need to know. So I said that the Foremost will operate at 2 different resolutions. So just to give you an example of what I mean, this is an example of a spectrum taken at low resolution, centered on the MGB feature around 5,200 angstroms. And the same region is reproduced below at resolution 20,000. And this is a synthetic spectrum, a simulation, of course, since the instrument is not operating yet. And we can see from the plot that we will be able to see many lines of interest, even for very low metallicity objects. And the range of operation, the wavelength operation of foremost is in the optical. So this is different, for instance, from moons, which will operate at about the same time, but on the VLT, and will be mostly centered on the infrared regime. So this is just to give you an idea of the wavelength coverage of foremost in low resolution, the lines below that covers almost the entire optical spectrum, and in high resolution, where there will be 3 wavelength regions where we can get information. And the lines just give you an indication of what can be reached with a single integration of 20 minutes, the basic unit of observation in foremost, and with 2 hours of observation, which is the default maximum length of any kind of observation for the entire service. So in high resolution, it will be possible to reach a magnitude of about 16 to derive precise abundances. But if we go to lower resolution, the 5000 resolution, it will be possible to derive stellar parameters, meaning, of course, also metallicity and alpha elements down to about 18, radial velocity down to about 20th magnitude, and it will be possible to obtain redshifts for fainter targets. Being a 4-meter telescope, it is not feasible to reach much finer magnitudes than that. And about the radial velocity possibility for foremost, since foremost is intended also as a complement to Gaia, this is to give you an idea of what is the expected precision in the foremost radial velocity determination. It will be below 2 kilometers.
Sorry, everybody. Can you switch off your microphones, because somebody has still the microphone on? Okay, yeah. Thank you.
Maybe you can.
I tried, but it looks like
it is impossible. Okay.
Yeah. Okay. So please.
Okay.
Thank you.
Foremost, we reach a 2 kilometers per second precision down to the Gaia limit of observation, while the Gaia spectra, which will be much more numerous, will reach a much worse precision and for much brighter sources. So it is an important complement to what Gaia can do, and is an important complement to studies done otherwise. So the consortium that built and proposed the service is operating in consortium, in so-called consortium service. So there will be 10 of them, 5 of them are stellar, centered on the Milky Way and the Magellanic Clouds, and 5 are extragalactic. And so we will have observation both in the Milky Halo and in the bulging disk of our galaxy, and in the Magellanic Cloud. And for all of them, there will be both low resolution and high resolution information. So there will be information on all kind of abundances from all nucleosynthetic targets for the brightest targets, and there will be at least metallicity and alpha elements and some abundances for very far away targets. So, as I said, beside the 10 consortium surveys, there will be 30% of the time dedicated to the community surveys that have been proposed. We sent a letter of intent about 3 years ago, and then a full proposal 1 year later. And the community surveys were selected and approved at the latest ESO OPC meeting in November, and then got the final go at the end of December. So of the 15 community surveys, there are 6 galactic and 9 extragalactic service, and 8 have been accepted as full independent service. So now there are 18 services in total running at the same time in Foremost, and 7 has been assumed as sub-service of the consortium service. Sorry about the service consortium, etc. And also INAF noticed the approval of that and put the news on his website. So the Galactic service selected are these ones, as I said, some of them as full service and some of them only as sub-service of an existing service. But I will deal today only with the ones for which there is a strong impact on the observatory here in Bologna, because one of them, the survey I wish to present today, Stellar Clusters in Foremost, as me among the PI of the survey, and 2 of them have a strong involvement of people working here in Bologna. I'm sorry if I forgot someone, but I took this information from the presentation given at the last workshop at that, and I have no access to the full proposal later on. So, for instance, one of the selected sub-service is called Foregrounds, and it's very interesting survey targeting about 100,000 RR stars in our galaxy in low resolution. And the idea is to use those stars to derive the 6D structure of the outer Milky Way, because RR Lyrae are very important tracers. We can know their distances, and they are old, so they can be found everywhere in the halo of our galaxy. And another service that have been approved is 4 dwarfs. And in this case, they want to target all the dwarfs galaxies observable from the southern hemisphere, plus a few of the streams that originate or are connected to the those dwarfs. For instance, the Sagittarius streams and the streams, the Omega Centauri streams. And also in this case, the observation will be done both in low and high resolution. And of course, this will be the most complete inventory of abundances and radial velocities for dwarf galaxies obtained as today. But I wish to say something on the Stellar Clusters in Foremost survey, which has a strong involvement here in Bologna. And this is the list of proponents, and I've just highlighted in boldface people working in Italy everywhere, in red people working here at the observatory, and in orange people working here at the department. So the involvement is very strong. This is a survey which has a strong leadership in INAF. And meaning also that there is a SCADA INAF to be updated later, and people connected with that have been warned and know about it. So as I said, the Foremost field is very large, and it is also of hexagonal shape, but this is not of importance today. And this is just a view of the field of view with all the fibers illuminated, so you can understand how many of them are. And the idea is that this kind of field is very important for stellar clusters. And just to give you an idea, I show here a few typical sizes. So this is a globular cluster, at least the central part of a globular cluster. The central part is fully covered by any instrument aboard the HST, and the surveys done until now from the grounds with multi-object spectra have been done with flames. So with a field of view with a diameter of 25 arc minutes, but the full field of view of Formos is 2.5 degrees in diameter. So this is very important because we will be able to follow not only the central part of the cluster, but all the cluster to its extremes, and also stars that have been lost from the cluster and that are in the stellar tails or in the halo of the clusters. And do we really need such kind of field? Yes, because until now, even the dedicated studies done on globular clusters, for instance, and for instance on the multiple stellar population in a globular cluster, which are indicated by the star-to-stars correlated variations in light elements like oxygen and sodium, and which are seen also using spectroscopy and special bands, which are used to highlight the difference in abundances between stars of different generation on different population in the clusters. Those stars have been done only on the central part. But the clusters extend much more than that. And this is a special example. This is Omega Cen, which has been observed with DECAM, and this is a 2 degrees field of view. And with this kind of coverage of the cluster, people have been able to separate the different stellar population of this cluster very far from the central part of the cluster, and to understand if there is a variation of properties from the center to the outskirts. And this means that it is possible to understand the different kind of phenomena that contributed to the formation of the cluster. And this, in this plot, what is shown is simply the ratio of blue and red stars on the main sequence, meaning high helium and low normal helium stars from the central part up to 1 degree from the center of the cluster. So you see that the fraction of stars falling in the two separate sequences change because of how the cluster was formed. And also in the case of open clusters, which are usually thought to be smaller example of stellar cluster, we really need to have a large field coverage. And I show here an example for a very nearby and old open cluster, M67. It's a cluster which has about the same age and metallicity of the sun. So it is a perfect twin of our sun, and it is important to study. And this is a 2 degrees field, and stellar stars which are members of the clusters are found not only in the central part, but also beside the formal tidal radius in the form of tidal tails. And the important thing for Formos is that we will be doing all our survey after the Gaia data release have been made public. So we can select the targets in stellar clusters with very high confidence. We can select member stars in the stellar clusters with very high confidence on their membership. And this plot just shows the case for 4 other clusters where we see that there is a concentration in the central part, and this is the part that we have been studying until today. But we also have a stellar halo and stars on tidal tails starting from the clusters. So with Formos, it will be possible to observe the entire surface of each cluster we are targeting. And our idea, our proposal, is to observe essentially all the visible open clusters in the southern hemisphere and all the globular clusters visible in the Milky Way and in the Magellanic Clouds. So this means that we'll be able to observe within the same surveys stars from the lower metallicity limit reached by the globular clusters to the very high metallicity of open clusters, from objects which are above the same age of our universe to objects that are forming now, essentially now. They are a few million years old. And the survey will be conducted both in low resolution and high resolution, and with the same proportion of stars that we have in the general service. We will coordinate with the planned consortium service. And with this kind of service and with this kind of observation on the whole population of stellar clusters accessible from the south, we wish to understand how the clusters formed and evolved and finally dissolved and populated the Milky Way, because even if most of the stars are forming clusters, we see now a very large population which is just in the general field. And we need to understand the interplay between stellar clusters and the general field of the Milky Way. Of course, stellar clusters being objects formed by coeval stars with the same metallicity and at the same distance from us are very important calibrators of anything that affects stellar evolution. So it is important to understand, to measure their general chemistry and to measure also the distribution, their kinematic and dynamics. And the targets have been selected, of course, in the southern hemisphere because we are observing from Baranal, and the limiting magnitude for the high resolution and the low resolution target is, of course, slightly different, and we will go to about 16 magnitude in high resolution and about 20th magnitude for the low resolution, meaning that for each cluster we will have both high resolution and low resolution targets. And I show here the case of just an underscript open cluster where we will observe the brighter stars in the cluster using the high resolution option, but obtain also low resolution spectra for all the population of the cluster. And it is important also in this case to observe on a large field of view because there are stellar members also very far away from the center of the cluster. So this is just to give you an idea of the numbers we are talking about. So we will have about 100,000 globular cluster stars and about 2,400 targets in open clusters and in very young clusters. The very young clusters are separated from the open clusters simply because the show stars are all still on the priming sequence, so the treatment of targeting and the analysis is slightly different, but they can be grouped together. So this is what we are asking about, what we asked about, and this is what we received in our survey. So the numbering is given in fiber hours, which is a strange way of thinking, but the important thing is that in the same field of view, since there are 2,400 targets observable, it is impossible to fill all the targets from a single survey. So all targets, all surveys will be put together in a single catalog, and in each observation, the same field of view will be shared by different surveys. So what will be produced by that? We will have a spectral classification, radial velocity, stellar parameters, elemental abundances for all the stars that we are observing. And this expected scientific outcome is here, but since it's late, I leave you to think about what we can do with all those information. There is someone talking. I don't know if it's Francesca telling me that it's late, but this is what you see. And just a few more information on times. So now, right now, all the services have been selected, and the community service are being integrated in the consortium, in the general consortium. So we will have a full simulation of the of the whole survey in a few months from now. We will have to prepare our final catalogs in about 1 year from now, and we hope to start all the observation in about 2 years from now. And then observation will go on for 5 full years, all on this service. And since this is a public survey, the raw data will be made public immediately. As soon as everything is observed, it goes to the ESO archive and is accessible to anyone. But also the so-called level 1 and level 2 data, meaning that the science-ready spectra, the level 1 data, and all the products of the science analysis will be made public, even if the schedule has to be decided yet, and there is some kind of reasoning with ESO to decide how long it will take since the observation start to the first public release of spectra and of products, because of course we need also to protect people working for the survey. So one important feature is that everything will be analyzed by pipelines, which have been built and are still under construction right now. So all the Galactic service will use the foremost Galactic pipeline that will analyze both the low resolution and the high resolution spectra, and will produce in a uniform and homogeneous way radial velocity, stellar parameters, and chemical abundance for the whole service. And for instance, this is what the Galactic pipeline plans to do. So plans to derive information and abundances for stars of all kinds of spectral type, from the white dwarfs to M dwarfs and to FGK stars. So last information that I wish to share with you, if someone wants to join Foremost now, after the service have already been selected. And so the answer is both yes and no. So the PhD students are most welcome to join the survey. The PhD students of people working already in Foremost. So if you are a Foremost member and you have a PhD student who's interested to work on Foremost, they are welcome. Researchers, we are at a higher level of that, can join either a single project or can try to join a survey. So each service has a limited number of people to be added to the list of participants, because already there are more than 600 members in the survey, adding the consortium service to the initial, adding the community service to the initial consortium service. So if you're interested, please contact someone who's already in one of the survey and see if it is possible to join either on a single project or on a more stable way. And with that, I think I've finished my time. And if you have any question, please ask.
Okay, thanks, Angie, for the very interesting talk. So time for questions. Let's see if there is anybody raising his hands. I will have a general question on committee surveys, the community surveys. So is foreseen future application for other projects in the future for community surveys, or? Not
now. This will go on for 5 years. Then after that, I'm really not sure what are the ideas of ESO. They will evolve and decision will be taken now. So at the moment, all the time on Foremost is dedicated to the public survey. So anything which is not in here now will not be here at least for the next 7 years.
Okay, thank you.
And at least this is what I understood.
Yeah. Okay. Other questions? Curiosities? No, nobody? Another curiosity, Angie. The 4 dwarf surveys you mentioned, okay? Yeah. So what kind of dwarfs are this project going to observe? Is kind of very nearby dwarfs, satellites of Milky Way?
Yes,
okay.
Satellites of the Milky Way.
Okay.
So
but very nearby.
I'm trying to find again the slide.
Okay.
You see the slide? So
yes.
This is what they propose to observe. If you see here, so there will be Sculptor, Phoenix, the Sagittarius and the Sagittarius stream, and this is what they will do.
Okay, so very nearby dwarfs.
They say all those galaxies in the southern hemisphere, but since I'm not in that survey, I don't know.
Do you know the details? Okay.
No, I'm not. Okay. Davide should know better than that.
Yeah, the farthest one will be 400. And then we'll try to target some ultra faint dwarfs as well, but they won't go far away.
Yes.
Okay.
And Karina.
Okay, thank you.
Yeah. Remember, it's a 4-meter telescope.
Yeah, of course. So
you cannot go too far.
Too far. Okay, other questions? So if there are no questions, let's thank again Angela. And see you on next Tuesday.
Bye.
Bye. Bye.
Bye. Thank you.
Bye.